Hello everyone, today is December 2nd and it's time to open up a new problem on LeetCode for our coding advent calendar. If you don't know what I'm talking about, then please check out my previous video. Anyways, welcome and let's start. Today's problem of the day looks like this. Determine if two strings are close. Two strings are considered close if you can attain one from the other using the following operations. Operation 1. Swap any two existing characters. That means, for example, you can swap B and E and they just change their places. Operation 2. Transform every occurrence of one existing character into another existing character and do the same with the other characters. For example, if you have A, C, A, B, B, then you can transform all A's into B's and all B's into A's, like this. And you can use this operation on a string as many times as necessary. And you are giving two strings, word 1 and word B, word 2, and you need to return true if word 1 and word 2 are close, otherwise return false. For example, ABC and BCA. You need to return true because you can achieve their closeness using the first operation. You can just change places of letters, like this. Apply operation 1, apply operation 1 once again. Example 2. You have word 1 A and word 2 AA. The lengths of these two words are different, and there is no operation allowed to change the number of letters in a word, so you cannot achieve their closeness in any number of operations. CABBBA and ABBCCC. You need to return true. You can apply operation 1 and change words like this, and then you can apply operation 2 two times by replacing one character with the other, and that's how you can get these words to be close. How we are going to solve this problem? So first of all, if input words are in a different lengths, then we cannot do anything to make them close. So immediately we will return false, right? I will make this a little bit bigger. Okay? So, what are we going to do next? If these words have different sets of characters in them, then we cannot do anything to make them close in any number of operations, because in one word there will be a character and we will not be able to do something with it in any number of operations. Okay? So we will somehow need to have sets of characters, but also we need to have a count of these characters, because we need to be able to apply operation 2, and it should be applied to all instances of the characters. So we need to have set with the count of entries in this set. The best data structure that matches our needs is hash map, and in .NET and C#, implementation of hash map is a dictionary. And I will create a helper function for me to transform word into a dictionary of a char to an int. Okay, we can remove this, remove this. So what I do here is I scan string s, I take letters from characters from it, and I put them into a new dictionary. If a letter already inserted into a dictionary, I will just add 1 to the value of a key value pair. If not, I will just add this entity in a dictionary with a value 1. So here I will transform word 1 into a dictionary, and I will do the same for word 2. Okay, now as I said, we need to check if sets of characters are the same. If they are not the same, like in one word there is a letter that does not exist in a second word, then we don't have any operation to fix that. So for this case we need to just check these sets. So what I'm going to do is to I will go through the first dictionary and check if every instance of this dictionary exists in a second dictionary. And also I need to do this vice versa with the second one. I will do this like this, like this, like this, like this. Okay, now when we are sure that sets are equal, we need to compare values, because as for operation 2 we need to transform all instances of one character to all instances of another and vice versa. That means that values of these hash maps should be the same if you sort them. So for example, if A instance in one word exists 2 times and B exists 3 times, and in the second word it's vice versa, then you can swap A's with B's, which means 2 letters with 3 letters, and you should get the same value as in string 2. That means that in first word the numbers of values in set should be 2 and 3, and in the second one it should be 3 and 2. That means if we sort these values in a dictionary, we should get the same increasing sequence of numbers. So what we are going to do? We will create 2 arrays of integers. So here in dictionary, values are integers, right? And now we are going to sort them. Okay, and now so these arrays should be the same length, because we already checked that these sets are equal, so values are the same length, right? So what we need to do here is to go through one of the array and compare values in a sorted variant of second array. And since both arrays are sorted, if they are the same, then each individual index in one array will match to the same value in a second array. Okay, if we found any difference in these sorted arrays, then we cannot do similarity closeness of these two words. Otherwise, if all our checks passed, we can return true. Okay, let's do a quick run. Okay, yes, let's do a quick run again. Okay, 330. Okay, here. Okay, yes. Okay, it works. Let's do. Okay, let's do it. Let's check with some more examples. A and AA. Run. Okay, that is correct. And here okay, that works. So let's try to submit our solution. Okay, and looks like it is correct. It passed all the checks. So let's try to estimate time complexity of our solution. What we do here, we have hash maps, and we store letters from both words into hash maps. That means we need to scan each word. that is big O of n operation, so linear scan. Then we do all operations with these dictionaries, and since we have a limitation that words have only English letters, it is here. That means that no matter how long our input words are, they use limited alphabet. That means that our dictionaries will be limited in size in any ways. That means that any other operations, including sort, are big O of 1, so constant time. So our time complexity for this solution is big O of n, because the longest operation here is to scan these strings and create a dictionary here. If we are talking about the memory, then we need to have a fixed memory, because as I said, our alphabet is limited, so we need a fixed amount of memory. So time complexity is big O of n, and memory consumption is big O of 1. So I think this is the best solution we can achieve here, because we cannot avoid linear scan of our strings. That's it for today. I hope you enjoyed the video and the problem we solved today. I will be back tomorrow and show you my solution for the next problem of the day. Before my video is out, please try to solve the problem yourself. Let's see if you can do better. See you tomorrow.